changes in organizational and commercial transactions. We're also seeing social processes being transformed, infrastructure that we more or less take for granted being changed, and the way we interact with each other. So this is changing the way we access our news, our information, we get our entertainment, access to education, but also physical resources like water and energy, also our access to medical treatment and the way we're going about transportation. Changing the way that we access our systems of justice, go about governance, and go about political engagement, and also changing the way that we access communal resources. So the challenge that it comes for us as engineers is the need to create ever more complex socio-technical and cyber-physical systems which will support and enhance this full spectrum of human activities. So I'm not going to look so much at the cyber-physical systems here. So I'm really going to look at socio-technical systems, and these are systems that involve some combination of intelligent devices and software, artificial intelligence, and people. Yeah? So we're trying to use a synthesis of human intelligence and computational intelligence to create these self-organizing socio-technical systems. Okay? They have to be self-organizing is because they're basically coming up with solutions to problems amongst and between themselves. Yeah? And we hope that this will support solutions to problems that are emerging in the digital transformation. And one of the examples that we give here is the one that I touched on last time, which is the smart house and the community energy system, or the smart grid. And so what we see here is that we have a house with a smart meter, and it has possibly its own way of generating electricity from renewable sources. It has a bunch of devices that it wants to power, and it has a way perhaps of storing it, and this includes a home battery, but also the electric vehicle. And we can see that if the amount of energy that was being generated was equal to the amount that was being used, there really wouldn't be a problem. It would be a nice one self-contained system. But sometimes the sun's not shining, and so we're not generating enough. So we've got to make up the shortfall from somewhere. But sometimes the wind is blowing, and we're fast asleep, and so we want to put it somewhere, and our batteries are full. Yeah. So the way that you do that, of course, is you get together with other houses and you form a smart village or a community energy system. But even that doesn't guarantee that you're going to generate and use exactly the same amounts of electricity on a daily or a seasonal basis. So you get together with other energy systems. And of course, what we also see here is that there are a lot of stakeholders involved in this process. So it's not just the people who are living in the houses that we might call the prosumers, but we have various other stakeholders involved. In particular, the entrepreneurs who are developing your apps, which are going to be running on your smart meter, which are doing the interconnections. The service providers, these wires and smart meters don't install themselves. Someone's got to do it. Someone's got to maintain it. You may have people who are pressing a certain point of view, so advocates for a Green Deal and trying to reduce energy usage and so on. Yeah? So we see a wide range of stakeholders. And so, as I mentioned last time, some of the issues that are actually going on here, what makes these systems so complicated is the fact that there are many layers of interaction. Yeah? So I identified 4 last time, where I, as a user, a prosumer, don't really care what's going on. I'm delegating it to my device to sort it out. This is the delegated, the human's out of the loop. There's the programmable level, where I can program my device to specify I want an operation within these certain constraints and boundaries. So now, after that, I want the device to negotiate my solution. So now my humans are on the loop. There's the interactive level where there may be a shortfall of electricity. So one thing we could do is actually turn some stuff off. So we actually want to get the people involved. Now the humans in the loop. And then there's the topmost level where you might want to make investment decisions. So you've got to pay attention to what's going on. And now the humans are the loop, and we might actually just be getting some decision support. So given these 4 layers of interaction, we then get interactions going on within and between community energy systems. So it's not just the fact that you're negotiating with others, but we get this polycentricity going on with all the stakeholders. There are multiple centers of decision making, and we have a system of systems. Yeah? So we have to pay attention to which direction the information is flowing in and which direction control is flowing in. And effectively, we're trying to solve wicked problems. So a wicked problem is defined as a societal problem which basically has no clear end state and actually no well-defined criteria for evaluating whether or not you're in such a state, even if there were one. And there's also no learning that you can do. So generally speaking, you've got one go at getting this right, and otherwise the system fails. And sustainability is perhaps one of the best examples of this. All that you can say about a common pool resource that you're trying to sustain is that you've managed to sustain it so far, but that doesn't tell you that for sure that trajectory will continue into the future. And as we're seeing with a lot of crises, you only have one go at getting this right, and otherwise, you know, like the islanders on Easter Island that used up all the trees, or on Malta used up all the water. Once you have a crisis, there's no coming back. And of course, I mean, really, I'm thinking of this at scale because anthropogenic climate change is precisely one of these problems, and we've got one planet and one go at getting it right. And the third thing we can see about this is that actually there are what might be called value-sensitive requirements, that we want to build systems which are sustainable, that are fair, that are effective, that get the right result, they're stable and legitimate, and they're incentivized. And one of the things that you can see about these is that these are requirements that are different from what you might expect the normal functional or non-functional requirements that as software engineers we would normally expect to have to design a system to meet. Yeah? So for example, I once was involved in a project where we were just doing some e-commerce, but it was to sell wine. Yeah? But actually the requirement was to build a website that would increase loyalty. Yeah? So it's a completely different thing to say, I want you to build me a website which enables me to sell wine. And another thing to say, well, actually I want you to build me a website that enables me to sell wine and increase the loyalty of the people to whom I sell the wine. Yeah? And so what this is that there's this functional requirement, build a website, and this supra-functional requirement, if you like, increase loyalty. And that loyalty is a value. It's a qualitative human value that we're trying to meet, sort of, in effect indirectly, but we actually have to design for this. And this is the idea of the methodology of value-sensitive design, is to put these supra-functional requirements at the focal point of design. And all of these things that I'm suggesting here about sustainability, fairness, effectiveness, legitimacy, and so on, these are all values that we want to try and maximize in our design. So what does that leave us to? Well, actually, every time I try to think about these systems, it depends on the perspective that I take on it. So I kind of think of it, you know, like how there's the Necker cube. You can see this thing here as solid or hollow, depending on how you manage to flick your perspective. And you can switch between these two things. So I've been trying to think about these systems. It's a system that doesn't have just two interpretations. It has about 6 interpretations. So depending on the particular context that I'm observing the design of these systems from, affects how I think about the solution. Yeah? So the 6 perspectives that I've identified is that there's effectively a knowledge management problem going on, which is how do we make information available for socially productive purposes? There's a collective action problem going on, that how do we achieve cooperation and coordination amongst autonomous entities, but doing that at scale? There's a governance problem, that how do we specify the structures and processes and checks and balances which will give us stable and legitimate governance? There's an incentivization problem, especially a prosocial incentivization, i.e. doing things for the common good. So how do you visualize these things, but in non-transactional economies? So economies of gifts, economy of esteem, information economies. There's an aspirational values problem. So how do I achieve correctness in the outcome of algorithmic deliberation decision making with respect to things like justice, for example? And there's a problem of identity. How do I make all these transactions and interactions suitably enhanced so I can establish trust between the people that are actually involved, and I don't damage privacy and so on, and especially when I've got no centralized authority that's taking care of these things. So these are the 6 perspectives that have been looking at this. And what I'm going to do is take you through 5 of them. I'm going to rush through them because frankly, each one of these is probably an individual, well, has been an individual talk in and of itself. So try and give you the whole flavor of everything. And there are 2 things I want to think about as an indirect implication. One about how we can use technology which can maximize or magnify benefits to people, but it can also exacerbate pathologies. But also, I finally want to get to as a point to show you how you can bring these principles together in the design of a system. So I'm going to look at each of these 5 things in turn and see how far we get. Okay. So the first one is about sustainability, and this is collective action for sustainability. So if we analyze collective action, there's some results from the 1960s. Yeah. So there's someone called Manke Olsen who came up with what he called the zero contribution thesis, which specifically said that unless the number of individuals in a group is quite small, or unless there is coercion or some other special device that will make individuals act in a common interest, then people will not act collectively to achieve a common interest. And this was also a feature of Gerrit Hardin's work, who talked about the tragedy of the commons. And this is how people will deplete a shared resource by overusing it. So his claim was that people will act to maximize their interests in the short term, even if it's not in their interest in the long term. And this is how you end up by overfishing, over logging, chopping down forests, depleting rivers for irrigation purposes, and so on. But these results have been the basis pretty much of what's been called mechanism design. So this is trying to develop an optimal system-wide solution to a decentralized automation problem. We've got self-interested agents, and they have private information about their preferences for different outcomes, which is all well and good. But these results were published in the sort of mid and late 60s, and 25 to 30 years later, political scientist and economic scientist Elinor Ostrom basically came along. I paraphrase her 1990 book by saying pretty much that that's not what we observe in real life. Yeah. So contrary to what both Hardin and Olsen were saying about cooperation, you could get people to cooperate at a large scale in such a way that they would not deplete a resource. And so the question, how do people go about solving this sort of problem? Well, it turns out that people are very good at making stuff up. Yeah? And in particular, they're very good at making up and writing down conventional rules which you use to voluntarily regulate and organize your behavior. Yeah? And of course, this is the absolute foundation of game playing. We couldn't play games if we couldn't make up rules and stick to them. Yeah? And the great thing is that actually complying with these rules creates what are called externalities. So these are things which when you have an interaction between 2 people, it's a benefit that occurs to a third party. And actually what happens is that, you know, this is just a wonderful feature of human invention. Not only did we make up rules, but we made up qualities that we associated with people who complied with these rules. And this is the basis of a certain type of conceptual resource, which is often called social capital. But I like to think in terms of conceptual resources, because they are simply a product of the social construction of shared reality that goes on when we do this kind of interaction. And that was the basis of what Ostrom observed, that throughout then history and geography, communities were able to manage and sustain common pool resources by evolving what she called self-governing institutions. And these self-governing institutions were sets of rules that were conventionally agreed. So the rules were made up. They weren't hard and fast like physical rules like gravity. They were understood by everybody who was involved. They had to be monitored and enforced. But crucially, you could change them. I mean, not only could you break them because they weren't like physical rules, but you could change them to make sure they fit circumstances. And so this is what she defined them as: a set of working rules that are used to determine who is eligible to make decisions in some arena, what actions are allowed or constrained, and certain prescriptions that forbid, permit, or require some action. Yeah. And as a result of extensive field work, she actually identified 8 common features of these successful CPR institutions. So it wasn't just the fact of having the rules alone that made sure that the CPR institution was successful. It also had to exhibit these 8 common features. And this work that she did in 1990 was confirmed with a meta-study 20 years later, with just a minor qualification. So effectively what this is giving us is what we might call institution design. It's a good enough system-wide solution to a decentralized satisfaction problem with self-interested agents who have private information, but also you're giving them a shared set of congruent values, i.e. the value here we want to sustain this common pool resource. And what this is showing is that actually, it's not that people are innately selfish or they're innately cooperative, but if you set up a game where the rational behavior is selfishness, then you will see selfishness. But if you want to change the outcomes, you put in a political metagame, which is essentially what the institution does. And so you make the rational action to cooperate, and lo and behold, you will see the emergence of cooperation. And this is what Ostrom's work showed. Yeah? So then she said, basically, if this is institution design, if you're faced with one of these collective action problems, don't trust to luck to evolve it so you get the right set of rules. If we know what the features of the institution are that are going to enable us to sustain this resource, supply them, design the institutions with these features inbuilt right from the start, and then carry on. Yeah? And so this is what she did. So she re-expressed these features as what she called institutional design principles. Yeah? And so this included clearly defined boundaries. So who was and was not a member of the institution, what was and was not a resource that was affected by it was clearly defined. You needed to have congruence between the rules and the environment. You needed to have those who were affected by the rules participating in their selection and modification and application, and this is what she meant by collective choice arrangements. They had to be monitored, you had to have and enforced, you had to have a scale of graduated sanctions, so it wasn't just a case of one mistake and you're out. And you needed to have fast, cheap conflict resolution. There was this minimal recognition of the right to self-organize. Every single word in that sentence is difficult, apart from of, basically, but essentially, for those of you who, I can't do the audience participation, so I assume that you're aware of a game called golf, which is played with unfeasibly long sticks, trying to hit unfeasibly small balls into infeasibly small holes an unfeasibly large distance away. So we're all familiar with that sport. So I play this game, but I'm not very good. So me and my friends, we have our own rules about how we play golf. We call it golf dash. But essentially, we're self-organizing our rules. But if somebody came along and tried to say, you can't do that, you're not playing golf, get off our course, we'd stop playing golf. And so this is why we can self-organize. We can change our rules to make it congruent with our abilities. And the last one was a system of systems, and this is how it would scale up. You'd have these local things which would actually then build up to cover some regional boundaries. Yeah. So we did this in 1990, and then this was when it was published, the book, and then there was a small financial crisis around about 2008, 2009. And for this, they couldn't really award the Nobel Prize for Economic Science to any one of the people whose equations had caused the financial crisis in the first place. So it was well deserved, but they awarded it to Eleanor. What's quite interesting, of course, is that she was the first woman to win the Nobel Prize for Economic Science, but very often, it wasn't that what she won it for showing that there was a third way between privatization and completely public was a way to manage resources, showing that there is another way of doing these things. People say, oh no, but she was the first woman to win it. So not actually showing that the neoliberal equations could actually cause untold damage. It's very unfortunate. This was my theory, and I did actually mention this when I gave this talk at one time, and then somebody put up his hand and said, actually, I was on the committee that awarded the Nobel Prize that year, and this wasn't actually part of our reckoning. So there was my beautiful conspiracy theory slain by an ugly fact. But I mean, whether or not they meant it, that's kind of what happened. So what do we take away from this? Of course, if you come up with 8 principles, this implies that you win a Nobel Prize for Economic Science. Right? This is the takeaway message from that. Right? Okay, so where are we going to go with this? One of the things that we did was actually show how you could implement these things in computer systems, and this is what we did. In actual fact, this provided us with the basis of algorithmic basis for sustainable CPR management, because we could turn these design principles into executable code. And show how you could even cyber physical systems or just ad hoc sensor networks, cloud computing and stuff like that could actually sustain a resource by using these principles. And if you took them away, it didn't work just as it would in a human system. Okay, so then the second thing is we've shown that it can be sustainable now. But does that mean that it is fair? Because you could sustain it by one person taking 99% of the resources and just distributing a little bit to everybody, and that's just enough to keep it going, as long as you don't take more than is available. So what happens when we actually say, well, I want it to be sustainable, but I also want it to be fair? So the question then comes, well, what criterion do you use to judge the fairness of your resources? And as we can see, there's lots of different criteria. There's egalitarian, envy-free, proportional, equitable, and so on. And so in any kind of question about this distribution of resources, you could ask which criteria you're using. And I believe I'm right in saying that labor disputes in Sweden start off with the unions and the management negotiating first over which fairness criteria that they're going to use, and then start trying to resolve the actual dispute. So, however, there's problems with this because there are limitations of these fairness criteria, because many are not appropriate under what's called an economy of scarcity. And this is what happens when you distinguish between satisfy and satisfice. So it may be that there's not enough resources to satisfy everybody, so give them everything that they want, but there may be enough resources to satisfice, in other words, give them enough to be going on with. So this is what happens in an economy of scarcity. The requests for the resources is greater than the actual resources that you have available, but you can still keep, give people enough. Sometimes they only focus on a single aspect, and they often really disregard temporal aspects, the fact that actually this distribution of resources is iterated, that we do it in repeated cycles. So the idea here is that we can actually use multiple criteria simultaneously, and for this we're going to use the logician Nicholas Rescher's idea of legitimate claims. Okay? So in this theory of distributive justice, Rescher identified what he called canons of distributive justice, so that throughout history people have found 7 ways of distributing resources. So you either distribute them equally, you distribute them according to people's needs, you distribute them according to the productive contribution that they made to securing these resources, the efforts and sacrifices they might have made, according to their socially useful services, according to supply and demand, or according to people's ability, merit, or achievements. And he argued that none of these canons on their own could be fair for every single possible circumstance that you could imagine that you would have to distribute resources on. And so what he said instead is that you actually had to work out which of these canons were applicable in context. Yeah? And these he called the legitimate claims. So what you have to do is identify which of the claims apply in the particular context that you're using. And then you've got to decide how you want to combine them if there's more than one, and then how to reconcile them in case of conflict. Yeah? And then we can appeal to Ostrom and her collective choice arrangements. Self-organisation says, well, let's let those who are affected decide which claims are important, are in context, and how important each one of those actually is. Yeah? And so we tried this with simulations with a linear public goods game. So this is where you have a group of agents who have to contribute a certain amount of resources to a pool, and then you decide how much that each agent gets because they make a request. And we ensure that there was an economy of scarcity, so you had to, some agents were going to go without. And we also said that the requirement was indivisible goods, yes, so you had to get everything. Yeah? And this meant that in any round of resource distribution, some agents were going to get what they asked for, and some were going to get zero. And there's no metric for identifying fairness, which is going to say that this is in any way, shape or form fair. So then what we did is that we had the agents and various algorithms to work out what weight they were going to apply to legitimate claims, and so use those to decide who was going to get the resources, and then according to how many resources people were getting, adjust the weights on the claims. Yeah? And what we found was that self-organizing the legitimate claims like this was the only method which produced an enduring system, which ended up being the fairest method. And what we see is, if you look at this graph, is we used actually the Gini inequality index to show how to measure the fairness. And as you can see, generally speaking, because there were some agents getting zero, it was between 0.3 and 0.45. But if we took that over time, and this is the green line here, how unfair the distribution resources were, it dropped close to zero. Yeah? And so basically what this meant that you could take a series of unfair allocations, but over time, and using the method of self-organizing legitimate claims, you could create a very fair allocation. So what this gave us was a number of design principles, actually, if you wanted to do put these aspirational values into your socio-technical systems. Yeah? I won't go into these because of the exigencies of time, but I just want to draw your attention to this last point here. It's this idea that values and preferences are not a timeless, infallible, and unquestionable product of votes. If we're going to do this sort of thing, you have to have a constant cycle of deliberation, recalibration, meta-deliberation. Are we actually getting our deliberation processes right? And continually sampling the environment to see that we are, what our values and preferences really are. So now we have some design principles for aspirational values, yes, but how are we going to find a way of making sure that we keep these rules in check, for example? Yeah? And so if it's sustainable and just, yes, and we know how to make it sustainable just. How do we now, again, self-organize the knowledge of that sustainability and justice? You know, what sets of rules actually make things just under what circumstances? What sets of rules make things sustainable under what circumstances, and so on. And there's a bit where I sort of hook into the talk last time, because one of the things that we can see is that the classical Athenian city-state, which was successful and sustainable for 180 years, and it massively outperformed the rival city-states on a number of metrics and a number of different domains: economics, architecture, military, and diplomatically. This was in spite of a relative parity in territorial size, population density, available of resources, and so on. And Josiah Ober's analysis in his 2008 book was that it was a particular feature of the political system, democracy, and it wasn't just the voting. Now, this was a real eye-opener for me, because I had the impression that it was all about, it really was literally one man, one vote at that time. But it wasn't just that they were all going down to the agora and doing the voting. What Ober's analysis shows is that actually Athenians were getting greater social benefits from the high level of cooperation that they made. And that gave them a superior capacity for solving collective action problems. And that was a particular feature of their model of self-governance. And a particular feature was this transparency of their knowledge management processes. So Ober showed that actually they had three main processes for organizing useful knowledge for socially productive purposes. So this was knowledge aggregation. This was how you would get information across a social network, so that the people who had to make a decision about something got to know about the right information to be able to make that decision. You had knowledge alignment. So this would be to ensure that once you'd made a decision, everybody would actually know about, well, this is what I've got to do. So if they were actually to go off and defend the city against the Spartans, for example, okay, you've got to turn up and we're going to have a scrap or whatever. So they would know what actions to take based on what decisions had been made. And then all of this was recorded. I mean, we have the expression carved in stone. That's literally what the Athenians did. They would actually carve these decisions in stone on their temples. And of course, this was useful for all sorts of ways, because first of all, it helped with transparency, so you knew who made the decision, but also what you could do in subsequent years. When you were faced with this problem, you said, oh, okay, well, last time we did that, and so maybe this kind of arrangement will help us sort out this problem now. And so you basically had these two cycles going on with these processes. You would do some collective decision making, which would give you some form of knowledge alignment, and that would be go into memory. But also, faced with a decision making problem, you could take something from the collective memory to create a process which would then carry on and feed into your knowledge alignment. And so this was the basis. Wasn't the one person, one vote thing going on. It was this ability to control knowledge flows in a coherent way. Of course, if we look at what happens to knowledge management 2,000 years later, we can see all sorts of things about how knowledge aggregation, is side affected by the the dominance of information sources and communication channels. That you get unequal distribution of knowledge. There's distrust of reputable sources and expertise. Elimination of diversity. One of the things that Ober stressed is that the knowledge aggregation methods made sure that there was knowledge diversity. So when you had knowledge that was relevant, actually it would get through to someone. We see filter bubbles and confirmation bias. So it's really hard to change people's minds in a time of polarization. And get all sorts of trolling going on with people deliberately injecting misinformation into the body politic. Problem with knowledge alignment, the idea that being an influencer is a career ambition for some of the younger generation. we see that real world actions are actually separated from what's going on online. So we don't get this observation of, if this is what the decision we've taken, this is what action we have to do. And we also get the private ownership of the means of social coordination. That actually being able to take collective action, of course, is blocked in part by the fact that we're not given the tools and the information to do this sort of job. And we see how knowledge codification has been undermined by a lack of common knowledge, a loss of a common narrative, a shared relatable experience between all of us, and that we're not all sharing the same set of values. So we're going to bring that back. We need some design principles for doing knowledge management for socially productive purposes in social media and platforms. And again, for exigencies of time, I won't go through all of these things. But just to stress a couple of down here is that we need these rules to provide a balance between expertise and majority. This is one of the common problems that any democracy has to face, that you have to find this balance between expertise and majority preference. And this idea here that the tolerance of dissent. So it turns out that my experience of designing computer systems in the early days of software engineering, we wrote about 30% of the code to actually do the functionality of the system. About 30% went on the interface, and the other 30% went on eliminating errors. Well, actually, it turns out that errors are really important in self-organizing systems, because this is the way that allows you to do some kind of exploration, so you can find a more efficient way of doing certain things. But it's also enables you to find out when there are procedures which are not actually having the effect that they wanted, and so you can bring about change. Yeah. So this is this point about enabling critics to expose inconsistency between core values and current practices. This is the way you have to do things, but it's not actually working. But the other way around is equally important, because we might have some rules. Now, it may be that you're doing a violation against the rule. It may also be that the person that's applying the rule is doing it wrong. Yeah? So you have to have some dissent of the citizens against to violate against rulers not doing what they're supposed to do. So that's the third one. The fourth one was this whole idea of stable and legitimate governance based on the simulation of basic democracy. And I don't know if anybody counted up the bullet points here, but you'll notice that there were 8 of them. Here again, we had 8 principles of democracy by design that I talked about last time. So again, I won't go into all of these at this point, but for those interested, watch the last presentation. It's all being recorded. Because I just want to finish off by doing 2 things. One, to talk about the 5th thing, which was about the prosocial incentives. And so one of the things we have to recognize is the centrality of transactions in the conduct of human affairs, but also that it's not always just a monetary transaction, and that there are actually some qualitative values attached to these transactions. And lots of different theories about this. So from psychology, there's Schwartz's theory of basic human values, saying that actually there are these things which are common across cultures. In philosophy and economics, the late David Graeber, who will be sorely missed, one of his first books was Debt, the First 5,000 Years, where he talked about the axial age and how it is that philosophical values started becoming more important than just the bits of coin that were being sought at the time. In legal anthropology, there's the work of Bronislaw Malinowski and his gift economies, and this is hilarious. So he studied the islanders in the Polynesia, in between Australia and mainland Asia, And what would happen is that you'd get one of these islanders and he'd make an artifact, a necklace or something like that. And then he'd get in his canoe and he'd paddle across this ocean at some risk to himself in order to present this necklace as a gift to somebody on another island. But it was the height of rudeness to then retain that gift. What that person then had to do was get in his canoe and paddle at some risk to himself over to another island, present that as a gift. And so it would go around, and eventually it would get back to the bloke that originally made the artifact and be giving it back. And of course, then he'd have to get back in his canoe and paddle over. The whole point of this is that these gift economies created these externalities. It created the relationships between the people on the different islands. So when there was a problem, they would all chip in and help each other out. Yeah? And of course, this is what happens in local economies. Yeah? It turns out that a unit of currency is a force multiplier. It's not just that I have a 1 krona coin, yeah, and I can spend it. It's the fact that I can spend it on a service to somebody else. They can spend it. That other person can spend it, and so on. And this is why we refer to it as currency and say that money is in circulation, yeah? Because that effectively creates a platform on which other values can be built. And of course, this is one of the reasons why these global transnationals are so bad, because if they take 20% of every transaction out of a local economy, you can only do that so long before it all ends up in some Panamanian bank account and the local economy absolutely collapses. As we're kind of seeing in the UK, there are some towns that are becoming ghost towns because of so much of the residences being bought up for Airbnb lets and so on. Various other different alternatives to this. Yeah. And of course, one of the things that we really need to focus on here is the role of communities in the creation of, as I said, these conceptual resources like social capital by virtue of social construction. Yeah. We've done some experiments on this to develop a computational social capital framework so that we actually had a way of representing and reasoning with our agents had this at any rate. Yeah. And out of all this work, we identified 8 principles of actual currency design, how it is that you'd go about designing electronic representations of these conceptual resources that you could work with. Yeah. I think, I mean, I won't again go through this, but just motivate it with an example. One of the things, I don't know whether you've had this, but we used to have a babysitting circle, and the whole idea of this is that you would have a token. If you were babysit for someone, you'd get a token, and then you could use that to get somebody else to babysit for you, and then you could go out and enjoy yourself in the way that you had. Yeah. And the thing is, what it meant was, if somebody had got all the tokens, it meant they'd lost, yeah, because they've done all the babysitting and haven't done any of the enjoyment, yeah. And actually that illustrates many of these ideas about, you know, what this particular currency is for. Yeah? The fact that you couldn't convert it into money, that it was basically a symbol of gratitude, not judgment. Yeah, and here I say, you know, monopolization meant you'd lost basically. Yeah? Oh yeah, and you couldn't just go around, you know, writing out your own tokens. There was certainly a certain number that were available. Yeah, so and this was a really great way of organizing the babysitting so that everybody can both babysit and you know, remember what it was like to actually, you know, before, if you remember that. Yeah. But there, 8 principles actual currency design, and they've fed into something that we sort of like calling computational axiology, and I guess many people are probably interested in cryptocurrencies and the like. And I find this really, really fascinating because it's a way of going for what we might call the stored value concept. Yeah? One of the major breakthroughs in the history of computing, of course, is the stored program concept. It's the idea of a series of zeros and ones could either be a number or it could be a instruction, or it could represent a truth value, or anything. Yeah? And actually what's really nice is that we can use these things to create any value that we want. It could be a unit of some cryptocurrency, but it could also represent a vote, a contract, anything that we want it to be. And so that there's something really quite fascinating that we might be able to do with distributed consensus technologies beyond just money laundering and requiring the same amount of power to compute the blockchain as it does to power a small city. But never mind. Anyway, that's computational axiology. And where is all this going? Well, because this is giving us a set of design principles, and now we want a target platform to aim that at. And this is a thing that I've been calling platform ocean. So platform ocean is two things. It's a meta platform. What it allows you to do is that you can download this platform and set it up on your server. And your server with a whole range of hosting options. It can be run on a Raspberry Pi machine in your own home, or it can run on your desktop, or it can be run on some hosting service in the cloud. Yeah. And then on the client side, every conversation that you're having with one of these servers just looks like it's all being accessed from the same app, basically. But we configure the interface according to what we want. Yeah. And then, so you download the platform, you customize it for your particular application, and then when you're finished, you feed it back in to the software repository that you got it from. So anybody else can come along and say, oh, that's nice. Yeah, I'd really like one of them. Yeah, and they can build on what you have provided. Yeah. So what is this doing? Yeah, so it's providing transparency at all sorts of levels, the hosting level, the client level, but also because all the interfaces, the APIs and the protocols are completely open, everything is transparent. We're a bit like Minecraft here, because basically you make available all these plugins. And so you can just shove these plugins how you want, but the idea of these plugins is that they're codifying all this deep social knowledge that I've just been talking about, everything we know about rules for sustainability, everything we know about rules for stable governance, everything we know about identity management, knowledge management, all get put into these plugins. The great thing is then you can use an instance of this platform to actually design plugins for the platform. And anybody can do that. And so you can actually get common pool development of the plugins for these things. And this, I believe, provides the basis of generativity. This is what the internet or the World Wide Web and the personal computer provided. It's a way that people could actually make tools that the original designers hadn't considered. Talked about the multiple server options. It's the fact that you can also then do visualization with one of these plugins, which is really, really important. So, of course, this is the black hole. For those of you who know about parkrun, we call this park runification, because the way parkrun started off was that just a small number of people doing this run, but they would see other people doing it and say, oh, that would be nice. I'd like to start one myself. And so, yeah, all you need is the way you do it. And so you could get going that way. Of course, for those of you interested in this sort of thing, there was a park run up in Haga Park. It's a rather nice one. I have done it, even though it's been cancelled. And the critical thing is, this is what Platform Ocean is about. It's an ecosystem. Yeah? And so you actually get all of these platforms, and they're connected together in a way, doing the system of systems that Ostrom herself was actually talking about. It. And the great thing about this is big tech companies can buy a platform, but they can't buy a meta platform, and they can't buy the ecosystem. So I think I just wanted to, if I may, can I
Sure.
show? Yeah, okay. One of the big problems that we're facing at the moment is single-use plastic, which is throttling the oceans and the cities, yeah, and we want to try and cool that down. So we had a small project which basically designed something that we called urban refill, with Platform Ocean as a target. And if I'm lucky, I hope I will be able to, excuse me, bear with me. Grr, that's the bear. If I share the screen, can you see this?
Yes. I'll now show you a short video to explain a bit more about how Urban Refill works. Welcome to Urban Refill, where our aim is to help communities reuse plastic bottles, form connections, and ultimately reduce plastic pollution. With Urban Refill, members and coordinators work in collaboration to refill plastic bottles of household goods such as shampoo, washing up liquid, and hand soap. As a member, you can make a profile, scan in your unique barcoded bottle, learn more about the products that you're buying, and connect with your community. Refilling a bottle is easy. Simply drop your empty bottle at the coordinator's location, who stores the products in bulk. Within 7 days, the coordinator will return your refilled bottle back to you. The coordinator scans in empty bottles to generate a refill workflow. Through the member map, the coordinator can see where the bottles need to be dropped off and when, so that a logical route can be mapped. Through the information page, both members and coordinators can ask questions, help each other, and chat. And finally, both individual and community achievements are displayed, allowing members and coordinators to see the impacts of their reuse on effects such as CO2 emissions saved and animal lives protected. As individuals and as a community, you'll earn badge rewards and reaching certain milestones, so you'll always know what a great contribution you're making. So that's Urban Refill, app designed to help you reduce plastic pollution, protect our planet, and connect with your community.
Sorry. I have to find it again. Sorry, could have all been done so much better. So that was it. I hope you enjoyed Urban Refill. And so just to summarize what I've been through, I'll start it off with Eleanor Ostrom's 8 institutional design principles for sustainable common pool resource management, which was the basis of a Nobel Prize. And I gave you 8 design principles for computational justice, 8 design principles for knowledge management, 8 design principles for democracy by design, and 8 principles for the design of actual currencies. So come on, what we know, 8 principles gets you a Nobel Prize. I mean, yeah, how many times has man got to do this before I get my nomination, right? So, I'm waiting. And then in seriousness, what this has shown is the Platform Ocean actually turns out to be quite a good target for design of apps like Urban Refill, which actually use those design principles to try to measure contributions to UN Sustainable Development Goals. And so this is the essence of what we're all about, is that ultimately we're trying to specify algorithms which produce just and sustainable societies, regardless of whether those algorithms are implemented in carbon or silicon or combinations thereof in the digital transformation.